An absolute value equation is an equation which contains one or more absolute values. We are going to use three basic properties of absolute value equations to solve problems. The first one, if the absolute value of x is equal to a, where a is positive, then x is equal to negative a or x equal to a. The second one, if the absolute value of x is equal to 0, then x is equal to 0. And the third one, if a is negative, then the absolute value of x equal to a has no solution for x. Example 1, the absolute value of x is equal to 6. By definition, the absolute value represents the distance of a number from 0. So the distance of a number from 0 is 6 units. If we move right 6 units from 0, that number is 6. X is equal to 6. And if we move left 6 units from 0, that distance is 6 units. So those two numbers are x equal to 6 and x equal to negative 6. The second example, the absolute value of x is equal to 0. The distance of a number from 0 is 0 unit. Well, that number is unique. It's x equal to 0. 0 is at the center of the number line. Solve the following absolute value equations. The absolute value of x minus 5 is equal to 9. We have two cases. It's either x minus 5 is equal to 9 or x minus 5 is equal to negative 9. We're going to add 5 to both sides. And x is equal to 14. We're going to add 5 to both sides. And x is equal to negative 4. So the solution set is x equal to negative 4 and x equal to 14. To check, you need to substitute both numbers back into the equation. The first one is negative 4. The absolute value of negative 4 minus 5 is equal to the absolute value of negative 9, which is 9. Now we substitute 14. The absolute value of 14 minus 5 is equal to the absolute value of positive 9, which is 9. The absolute value of 6y plus 18 is equal to 0. 0 is at the center of the number line. Therefore, 6y plus 18 must be equal to 0. When we subtract 18 from both sides, 6y is equal to negative 18. We're going to divide by 6, and y is equal to negative 3. So the solution set is negative 3. The absolute value of 7 minus 12x plus 15 is equal to 4. We're going to subtract 15 from both sides. The absolute value of 7 minus 12x is equal to negative 9, and there's no solution because an absolute value is always positive. the absolute value of x squared plus 2x is equal to 3. Two cases, x squared plus 2x equal to 3, or x squared plus 2x is equal to negative 3. X squared plus 2x equal to 3. We subtract 3 from both sides. It becomes x squared plus 2x minus 3 is equal to 0. This is factorable. It's x plus 3 times x minus 1. And x plus 3 equal to 0, or x minus 1 equal to 0. X is equal to negative 3, or x is equal to 1. So the solution for this, the first case, is negative 3, 1. X squared plus 2x plus 3, when we transpose negative 3, is equal to 0. Now, this expression is not factorable, and when we calculate the discriminant, we get 2 squared, which is 4, minus 4 times 1 times 3 is 4, minus 12, which is negative 8. No real solutions. Therefore, the solution set is negative 3, 1. Four times the absolute value of x minus 6 minus 1 is equal to 7. We add 1 to both sides. 4 times the absolute value of x minus 6 is equal to 8. We divide both sides by 4. Now we've isolated the absolute value of negative 6, and it's equal to 2. We can consider the two cases, x minus 6 equal to 2, or x minus 6 equal to negative 2 to find the solution. We'll add 6 to both sides, and x is equal to 8 for the first case. We add 6 to both sides, or x equal to 4. So the solution set is 4, 8. The absolute value of x squared is equal to 4. If we're considering real numbers, we would just set x squared equal to 4, and x is equal to plus or minus square root of 4. Therefore, x is equal to plus or minus 2, and we should be done. Because look, if we consider the negative case, x squared is equal to negative 4, no real solution. So the solution set is negative 2 and 2.